We have learned about data range and its mean in the previous video. Let us now understand the other measures of central tendency, median and mode. Like mean, mode is also a representative value of the group. Let us take the data for the number of runs for Virat's 7 innings. If we were to create a table for these runs using tally marks, we would observe that the smallest number, 59, appears only once in the range of data. We will therefore draw a straight line in front of it. Similarly, we will draw straight lines for 65, 70 appears 3 times. We will draw 3 straight lines against it. As well, 85 appears 2 times, considering that we will draw 2 lines. Now, considering table, we know now that 70 is the most frequently observed observation in this group. We can call this as mode of the group. Now, if we were to arrange this group of runs in ascending order or descending order, they will be marked as shown here. We will see the mid value is 70. This value divides observations into 2 equal groups, each of which has 3 observations. When a range of data is arranged in ascending or descending order, the middle value on the range is known as the median. As you can see, in this case, the mode and the median on a range are the same observations. However, this may not always be the case. The mode and the median can differ. Let us take another example to understand this. Listed here are the number of runs in some of Rohit's innings. We see that 35 is observed 3 times in the range, so we can call it the mode of the range. However, on arranging the observations in ascending order, the middle value is 29. That is, the median is 29. Thus, the mode and the median are not equal here. The number of observations in these groups of numbers is an odd number. So, the median of a group of numbers can be found identifying the middle number when the observations are arranged in an ascending or descending order. Can you think of how median will be deduced if the number of observations is even? Can you guess? Well, let me explain. In cases where the number of observations in a group is an even number, to obtain the median, we arrange the numbers in ascending or descending order and derive the mean of the middle 2 numbers. So, for example, for the set of observations 21, 23, 27, 29, 35, 35, numbers 27 and 29 are the 2 middle numbers. To find the median for this data, we first derive the mean of the 2 middle numbers. 27 plus 29 divided by 2 is equal to 28. Now that we know that the mean of these 2 numbers is 28, we can deduce that the median of these observations is 28. Even though 28 is not a part of the data provided, it divides the group of data into 2 equal parts. Let us now look at another interesting example. Here is the data of colors of balloons and their corresponding numbers sold by a balloon seller. Do you think an understanding of mean and mode will help the balloon seller identify the color of balloons that he should buy more? Can you think how this information will be helpful? Well, let's see. On obtaining the mean, the balloon seller will be able to derive the number of balloons that he is able to sell on average in a given time frame. However, from this, he will not be able to decide upon the color of balloons that he should be procuring in more numbers. This is where an understanding of mode will come into the picture. From the data available, it is evident that the balloon seller has sold more red-colored balloons than any other color, which means that the mode is 25. It can therefore be inferred that he should buy more red-colored balloons so that he has sufficient number of red balloons for sale. In this way, we need different representative values in different situations as per the requirement. Friends, wasn't it exciting to learn about the measures of central tendency, median and mode? In the next video, we will see some more interesting examples related to these measures of central tendency.